Okay, this is our chapter 3 homework. Let's just call it kind of like tips and ways to kind of navigate it. Okay, so let's start here. And again, the way I do this is I print out the homework assignment. I do it, write myself some notes, and then I'm going over the PDF with you. But what I did learn is that each time you do the assignment, it obviously changes things slightly. So even what I did is going to be different than what's on the screen sometimes. But it's also going to be different than what you have seen. So, okay. What we've got here for number one is we're just kind of trying to do some applications of demand and supply in general here in chapter 3. And what we're trying to see here is that if we have differing slopes for the supply curve, how does that change when the demand curve shifts? How does that change things? And so in each of these cases here, you're dealing first with the horizontal supply curve, and you are, in this case, increasing the demand. So here what we would see is that if I increase the demand curve, we'd get none of that change in the price because our supply curve is horizontal, but we'd obviously get all that change in the quantity. Now we are increasing demand with a standard looking supply curve, causing both our changes in price and quantity. And then finally, we're dealing with the vertical curve, same increase in demand. And here we see no change in the quantity, but we do see all the change in the price. And then it just asks you to identify that new equilibrium, which you should be able to do pretty quickly in each of these kinds of cases. Now, what does that tell us here? What it starts to get you to think about is that understanding the equilibrium does require that you've got a bit of a appreciation for an appreciation for both the shape of the supply curve and demand curve mattering. When you no, there's actually nothing more I need to say about this. Again, yours might be different. You might be seeing decrease in demand, but it's the same kind of analysis that you'd be doing here. In number 2, we've got my alma mater, Notre Dame. Talking about the perennial problem that we have of finding a room on football weekend. Well, I don't know if I have that problem. I don't know. I figure it out. Okay, let's just look at this here. Here, what we're trying to guess here is what the shape is going to be of the supply curve. And we have to do that given this evidence that we've got the demand curve shifting to the right, that the prices go up dramatically. And that these hotel prices are much higher on football weekends than they are on other weekends. So what would cause that? So the idea here is that even if you were just to kind of roughly sketch this out with a demand and supply curve, that yes, during a football weekend, the demand would be higher for rooms because of the football weekend. The price would be higher, but it would just be kind of a standard amount. But what we're told here are words like it's much higher. Hotel prices are shooting up, which means that we're seeing a much more dramatic change in the price that we would see, for instance, if we were just dealing with a vertical supply curve. Because then everything is all about price changes. So we've got our hotel supply curve with our hotel supply curve here being likely vertical here, then assuming it's vertical, start to draw it out. Because you faced these three choices here before you got to this part. So when you're doing it when you're doing it online, it's not going to present to you this second part until you answer this first part. I've demonstrated to you why it's likely vertical. Then they say, okay, let's go with that vertical thing, and then just draw a new equilibrium. Okay. Now we've got two sort of definitional or theory questions. In the first one, we're talking about the change in price from a leftward shift of the supply curve, a leftward shift of the supply curve. That would be a decrease in supply. And then we're sort of asked, what would that, if we're talking about the change in the price, when would it be greater? Would it be greater if the demand curve was more, essentially more steep or flat? I guess is really what we need to decide. So if it was flatter, let's just say completely horizontal, then we would see no change in price. So we pretty much know that it can't be relatively flat. And we can't have it really be horizontal. Really, we're only left with option C. And here we would see that because if we decrease my supply curve, but now I have a let's say a relatively steep demand curve, now we're going to see a lot of change in the equilibrium price. Then in number 4, which is related to number 3, if the demand curve for the good is horizontal and the price is positive, then what are we going to see with that leftward shift of the supply curve? In essence, this is the opposite of number 3, and it's going to go back to this idea of this graph right here, where we saw no change in the price if it's completely horizontal. Again, I understand I'm giving you some of the answers here, but really what my goal here is just to make these homework assignments seem less intimidating. Okay, for number 5. In number 5, we're given a demand curve. We're given a demand curve for broadband service, and we're given what that curve looks like for both small firms as well as large ones. Geez, that's horrible subscripts. You would never see me do this to you on an exam. I would not make it Q subscript S because that might make you think quantity supplied. Instead, they're saying quantity from small firms and then quantity from large firms, Q subscript L. Okay, so the nature of this form here is 15.6p to an exponent, and then for large firms, 16p to an exponent. And then we're asked to say, what can we say about the elasticities of demand on the two demand curves at the point where they cross? Well, just graph it out. So if we've got two intersecting demand curves, one for small firms, one for large firms. It doesn't even matter which one I make which. But at the point where they intersect, at the point where they cross, what is true? Is it true that the elasticities for both types of firms are based on the same quantity? Well, yeah, because it does go down here. Are the elasticities of demand based on the same price? Yeah, they are. The elasticities of demand are based on the same change in demand with respect to the change in price. Well, no, because once we start changing it, we actually would start to move along these curves. So C is not true. And because C is not true, then E can't be true. Both A and B were true. Thus, we're stuck there. Then what they do in the second part of this is they say, okay, let's take the first derivative. So to remind ourselves here of the rules of mathematics here, that would mean that how'd they get this? Because that would be negative 0.563 times 15.6 negative 0.563 minus 1. 15 point, just to confirm for us here, 15.6 times 0.563 gives me negative 8.7828. P to the point negative 563 minus 1, that would be negative 1.563. So that's how they got that. You could then repeat that process here, and you would get this. And now we can make a more general statement. What can we say about the elasticity of demand more generally at other prices? Hence the reason why we couldn't say that it was C in number 5. So what can we say now more generally? Well, what we can say more generally is that the elasticity of demand for small firms, well, that's our thing right here, right? That's my small firms one. And so what form does that take? The form that that takes is my elasticity of demand for small firms would be negative. There you go. Negative just what we see from the chapter here, it would be my first order partial derivative, my negative 8.7828p to the 1 to the negative to the negative 1.563 power times p over q. And then for the large firms, it's going to be this times p over q, which gets me this option right here. And again, this is definitional, that what we're looking at here is dq dp, which is again my first order partial derivative with respect to my function, p over q. And that's all we did here. We took that function that we were given here times p over q. And that's what we did here. Okay. Number 7. Coconut oil. So here we've got the coconut oil demand function. There's Perloff. This is one of his earlier pieces of research. He used to do agricultural economics, if I'm not mistaken, hence his love of hogs. But here he is doing coconut oil, and we're given various prices. And all we essentially need to do is substitute in those prices into our function. And then what we need to do is we need to take, let's see here. Right, so setting this up, you would start to take the first order partial derivative with respect to income, which in this case is going to be 0.2. And that partial derivative with respect to income, so that income elasticity of demand, the 0.2, times, now over here I've got my y over q. My y in this case is, sorry, I'm just finding it here, 897, yeah, over 1383. Okay, so 0.2. Now my q is given here. It's 1383. And for my y, I would need to solve for it. So in solving for it, sorry, let me resolve this here. I'm going to pause here just so this video doesn't get too long here. I'm just going to resolve. Okay, I guess it erased it here as soon as I tried to write this. So let me do this again here. Okay, so again, my numbers are probably going to be a little different than yours. So let's just rewrite this again. It's asking us for the income elasticity of demand, which we know to be delta Q, delta Y, Y over Q. My Q here is 1383. My Y, well, to get to that, I'm going to have to minus 9.5 P plus 16.2 P plus 0.2 Y. So now I'm going to algebraically rearrange the terms. So I'm going to negative 0.2y equals 1200 minus 9.5 p plus 16.2 pp minus q. Divide each side by negative 0.2. It's going to make my negative q a positive. I'm just going to put my q out in front here. Minus 1200 plus 9.5 p plus 16.2 pp divided by 0.2. Again, I just took the negative and I just made my, I moved my negative to the numerator instead. Now what I can do is substitute in my P, which in my case here is 48 cents a pound, and then my PP, which would be 31 cents a pound. I'd suggest just putting in like 0.48 to stand for 48 cents, and the 3.1 is 0.31. The problem that you could run into is that it's stating here that the price is in cents per pound. So technically, to get the right, so if you're doing this in the problem set, I would take either. Unfortunately, the book I don't think is designed to take either, so that would mean you're going to have to put 48 as your actual P and 31 as your actual price here. So that would mean we then have y equaling q minus 1200 plus 9.5 times 48 plus 16.2 times 31 divided by 0.2. When I did mine, mine was 47 cents a pound. I don't want to have to recalculate this, but if you follow the steps that I just put here, your delta Q delta Y here was 0.2. Where am I getting that? Because that's my coefficient for my income term. So my delta Q delta Y is 0.2. Then for my Q, that would be, in this case, 1383. And my Y term is going to be this that I'm going to put in my numerator here. And then we solve. And you're going to get actually a pretty clean number. In my case, with my number here being 47 cents, I got 0.9. Here in number 8, we're looking at the sign of a cross-price elasticity. And so we're looking at this for airline tickets with respect to bus tickets. And so because that's a negative term, that's going to indicate to us here that we're dealing with complementary goods. And then when we change things here, what we would see is that if the cross-price elasticity itself is 2.4, and we're changing it by 4%, then we would take our, in this case here, we would take 2.4, 2.4 times 2, which would give you 4.8 right there. Multiplying our cross-price elasticity times the change in the price of gasoline itself. Okay. Then we're dealing with something largely definitional here. And what you're working through here is you're just talking about the elasticities and how they're changing when we're talking about something being short run versus long run, talking about things being of higher quality, and then talking about what it looks like when the demand curve is relatively flatter. So these you should be able to answer just definitionally speaking, where we see that if in the short run we tend to see a bit more inelasticity, that we see greater elasticity when things are of higher quality because they're generally more expensive, and and we see here for the supply elasticity of higher quality tequila, what we saw here was that the price hadn't changed at all. So that would give us a good indication that it's probably shaped where the demand curve is. The supply curve is quite elastic. And then finally for the demand curve here, that it must be pretty inelastic because we are seeing that larger drop in the price. So again, just as you're reading this, I just had to kind of graph things out on the side to kind of get a sense of what was going on. Here in number 10, what you need to do is you need to solve for P. So that would mean setting these equal to each other, solving for P, and then substituting in for quantity. And once you do that, what you're doing is comparing it to its old price of 50. So what we had to do here is you had to change that when my price was 50 before, now what I need to do is change this from 70.5 to 68.5 to reflect the change in the supply curve that comes from having 5 million fewer barrels. So that's going to take us to, sorry, I'm just looking at this really quickly here. Oh, sorry. I was like, why is that 5? Mine was 2, sorry. You would be taking yours. So I took mine, it was 2 million barrels a day. So I took mine down to 68.5. Sorry, in this example, you'd be taking it down to 65.5 and then resolving it and putting in how much the price is changing by. So you basically need to solve it once with this given data. Then you're going to need to adjust the supply curve by the amount that it gives you here and then resolve it. And that should be giving you your answers here. Then you, for number 11, here you've got supply curves crossing, and you're essentially going to be drawing one where it's more elastic. So if it's more elastic and curves cross, then the more elastic curve of crossing supply curves will be the flatter curve. #12 should be largely definitional. And what we're seeing here is that if the demand curve is more inelastic, then people will still buy the good in about the same quantity, even though the price has gone up because of the taxes. So there we would see larger increases in tax revenue to the extent that the good is inelastic. You'll raise a lot more money. Such as now taxing toilet paper. But you don't want people then to, certain people to cut back, right? Because that would pose sanitation issues. Or it would be like pharmaceutical drugs. But again, you don't want people to not take pharmaceutical drugs because of the diseases or the ailments that they could have. But generally, again, we're going to see the demand curve to the extent that it's more inelastic. To the extent that it's more inelastic, that because these customers are less sensitive to price, they're still buying the same amount, they're going to raise more money. Okay. Now, when we're dealing with the subsidy for new homeowners that people were given back in 2010, now what we would need to do, it's asking us, how would things change here? The way that things would change, what's going to happen here? Well, it's going to increase the price, right? Because the house subsidy is going to mean that our demand curve is going to shift to the right. So we're going to be raising the price, raising the quantity. So we'd see increase and increase. Then in terms of who gets that subsidy, or how would it look? Well, the way that it would look is that it's going to be the difference in our subsidy from our pre-subsidy time period to our post-subsidy time period, so the new equilibrium, but then we have to take out the $8,000. Okay. Now, we actually do see here in number 14 an application of why we calculate inverse demand curves, and we do that largely when we're faced with taxes. It makes solving things a little bit easier. And essentially, we're going to be, so they kind of outline here how they got from our demand function, our inverse demand function, and our inverse supply function, what the sharing of the taxes, the share borne by the consumer. Sorry, I just hit the pause here for a second. Sorry about that. Okay, so here, what we're doing here is we need to look at for our elasticity of demand. The elasticity of demand is equal to 1 over negative B, P over Q, just by definition. What they're just referring to is just E. And then I like to write it out as E subscript S to stand for elasticity of supply. They just, they use this. But what is it by definition? In this case, it would be 1 over, now my D term here, D, P over Q. Which, if we look at this here, looks to be like the letter A here. So this should be just definitional. And then number 15. Sorry, I'm not trying to rush through this. But I don't want this video to become just as long as a lecture video. Consider the graph at the right. Assume that we have 5,000 pounds of lobster at a price of $50 a pound. Here they're doing a $20 tax. When I was printing out mine had a $10 tax. But whatever it is, whatever your tax is, that's how much you're going to be shifting. That's how much you're going to be shifting. Didn't mean to cross it out. I just meant to underline it. That's going to be how much you vertically shift your supply curve by. So in this case, you would shift it up by 20. And then you would just say what our new price paid by the consumer, price ultimately received by the producer, and then our amount of tax revenue. Number 16. This is largely definitional as well. Here we're just talking about what happens if the gas tax here is roughly shared equally by consumers and firms. And what could we say about their elasticities? Well, then they must be roughly equally elastic. What do we mean by that? Meaning that they have the same magnitude. Obviously, one is negative and one is positive, but they're about the same coefficient. Because you could draw it out and prove that to yourself, but that is true. Now, in the second part to this, if the supply curve is vertical, then what would we see? Well, we don't really know. And the reason why, if the supply curve is vertical, then looking at the tax on the price and the quantity, it's not going to tell us anything about the elasticity of demand because all the tax would be falling on the consumer, on the producer, because that supply curve is vertical. We'd have no idea. about the elasticity of demand from just the price and the quantity itself. Here in number 17, we basically have an application of the total revenue test. Again, I don't want to get into any detail here. I just want to keep this short here. So here, you're going to be applying the total revenue test to get this. So if something is unclear here, go back to the book and go to the total revenue test, or send me an email that you're specifically really confused about number 17 and want me to do it. And then, sorry, I'm just trying to go faster to not make the video long. And then in number 18, what we're dealing with here in this rather lengthy question here, what you're dealing with here is you're given a demand elasticity and a supply elasticity, and you're given relevant prices and quantities, and you need to take that information and then solve backwards to get the demand and supply function. What is useful for solving this, because again, now you're going backwards, would be that you go back to this question, question 14, and work backwards, and you'll be able to get back to your inverse demand and supply function. So basically, number 18 is the opposite of 14. Okay.